An empirical formula is the simplest whole number ratio of atoms in a compound. If you're given a molecular formula and it's asking you what the empirical formula is, you'll just reduce. In the next video, you'll see that going from empirical to molecular, you have to multiply. So below, you have two molecular formulas. If you look at those formulas, you can see that they can be reduced. Just so you know, empirical and molecular can be the same thing. So if it can't be reduced, the empirical and molecular are the same. So in this case, we see that 2 goes into both 4 and 10, so this can be reduced to N2O5. So this would be the empirical formula. For C6H12O6, you can divide that by 6, which gives you CH2O. The first step to solve an empirical problem is they're going to give you either percents or grams. So this should be your first practice problem, and we're going to go through those steps that are listed above it. So if they give you percent, you're going to convert each percent to just decimal form, which is basically just saying you have 71 grams of chlorine, 24 grams of carbon, and 4 grams of hydrogen. So now we have grams of each of them. You're going to divide those grams by molar mass to find moles. So step 1 is basically we're converting to moles. When you divide, make sure you're dividing by just one element of one atom of the element. Chlorine, although it normally is diatomic, is in a compound with these other elements. So you're just dividing by 35.5 or 35.45, carbon divided by 12.01, and hydrogen divided by 1.008. Then you're going to divide each answer by the smallest number of moles, because we're trying to find a mole ratio. So of these, 2.02 is the smallest, so we're going to divide all of them by 2.02. At this point, it's either going to come out to a whole number or something very close to a whole number or a fraction number. So if it comes out to a fraction number, you're going to leave it as a fraction, and then we'll have to do the next step, which is multiply to get whole numbers. In this problem, since it came out to whole numbers, we don't do step 4, and our final answer is 1 chlorine, 1 carbon, and 2 hydrogens. It doesn't matter the order that you list the elements in. So let's see that one again, but from the beginning. Here we have NutraSweet, and they're giving us the percents of each of them. So step 1 is I need to write my grams of each of my elements. Make sure that you're writing neat. There's a lot of steps involved, and so if you're writing sloppy, you may get messed up throughout the problem. And so it's a lot of time to waste on a problem if you're being messy and mess up a number. So I have my grams of each. I'm going to convert all of these grams to moles. So for carbon, that's dividing by 12.01. Hydrogen, remember, is just 1.01. Do not use the diatomic masses. That's the most common mistake people use or do. For nitrogen, we have 14.01 and oxygen 16. So then we get our moles of each of these. And so looking at these 4 moles, nitrogen is the smallest. So we need to divide all of the moles by 0.693. Or 0.6795, I should say. So dividing those out, we get 7 for carbon. For hydrogen, we get 9. Or for nitrogen, we get 1. And for oxygen, we get 2.5. So looking at these, 3 of them came to whole numbers, but 1 of them didn't. So 0.5, we're going to need to multiply all of them by 2. And let's go and make that a different color just so you can see it a little bit better. So we're going to multiply it by 2, We're going to multiply that one by 2, and by 2. So finally, our formula, we should have 14 carbons, 18 hydrogens, 2 nitrogens, and 5 oxygens. And so that's our empirical formula for NutraSweet. And just a reminder, remember if you had written H18, C14, N2O5, that's fine. As long as the elements and their subscripts are correct, the order will not matter. So this problem is more complicated. You may want to pay attention more carefully or star this problem. This is a combustion empirical problem. So with a combustion empirical problem, you have a hydrocarbon. So in this case, we have carbon, hydrogen, and nitrogen in a compound. That compound weighs 0.1156 grams. When you burn it, it's going to react with oxygen, and it produces so much CO2 and so much water. Sometimes they'll say it produces SO2 or NO2 or NO. You're going to follow the same steps. So again, in this problem, we have so much carbon, so much hydrogen, and so much nitrogen. We're trying to find the formula of this compound, what X, Y, and Z are. From the CO2 and water data, we can't determine how much oxygen is in the compound because oxygen can come from the atmosphere. So we can only use the CO2 and H2O data to find out how much carbon and hydrogen were in this compound because all the carbon and hydrogen came from this compound. So the first thing we're going to have to do is use our data from CO2 and water. And I would also recommend writing very small for this problem because it's going to be a lot of steps. So step 1, you rewrite our amounts out. And from the percent comp video, we need to find out of that 0.1638 grams of CO2, how many grams of it is carbon. So we set up our chart like so. We had grams of CO2, so grams of CO2 has to go on bottom. We're trying to find out how many grams of carbon are in this sample. So for every 44.01 grams, which is the molar mass, 12 of that is due to carbon because there's one carbon. Multiplying and dividing, we get that of this 0.1638 grams, 0.0447 of it was carbon. Now we're going to do the same thing for water. The difference is we have grams of water on bottom and grams hydrogen. Of that 18.016, 2.016 was due to hydrogen. So notice I have the mass of 2 hydrogens because there was 2 hydrogens in water. Multiplying and dividing, I get my mass of hydrogen. So the problem is now very similar to what we've done before, but I have carbon, hydrogen, and nitrogen. So to get my nitrogen, I'm going to use this 0.1156. That was the total mass of the compound. I know how much of it was carbon and how much was hydrogen, so if I subtract that amount, or my carbon and hydrogen from the starting amount, that's going to give me my mass of nitrogen. Now I have my 3 starting amounts, which is now the starting point that we've started with for the last 2 problems. So once you know the mass, we need to convert all of these to moles. So just for reference, now we have this starting off point. So now we need to do all these other steps. So the only thing that makes this problem more difficult is you have to do this initial step. So I have my grams of carbon. I need to convert that to moles. And then I have my grams of hydrogen. I need to convert that to moles. And I have my grams of nitrogen, and I need to convert that to moles. Again, I'm dividing by 1.008 and 14.01 because this is all part of a compound. So comparing these, I can see that 0.00372 is the smallest number, so I'm going to divide all of them by that. I'm going to move this over so you can see a little bit better. So we can see that we got whole numbers for everything. So we have 1 carbon, 5 hydrogens, and 1 nitrogen. And that's what our answer is. So CH5N. Okay, go ahead and try this one on your own. Restart when you have your answer or if you get stuck in the middle of the problem. So for this problem, your answer should have been NH2. So if you got that, good job. If not, you should have started with your NO2 and your water. In this case, we only have 2 elements, nitrogen and hydrogen, so we won't have to do a subtraction. We need to find out how much of this was nitrogen. And of this one, how much was hydrogen? Now that I have my 2 masses of starting elements, I need to convert them to moles. Then I compare my moles. 0.213 is smaller, so I'm going to divide both of them by 0.213, which then gives me a 1 and a 2. So 1 nitrogen, 2 hydrogens. Again, make sure you're being very neat. Sometimes people solve all of this and then they flip the numbers when they write their answer because they weren't paying attention to this one was nitrogen and this one was hydrogen. So notice I'm putting hydrogen throughout the problem, or on some I start with it off to the side so you can see what element it is, and then double check before boxing in my answer that I've put the correct subscript with the correct element. All right, go ahead and try this one. Restart when you have your answer. So toluene is C7H8. This one was a little bit tricky at the end. So you should have started with your grams of CO2 and your grams of water. Just like the last problem, we only had 2 elements, carbon and hydrogen. First, we find our mass of carbon and then our mass of hydrogen. From this point, remember that we need to convert them both to moles, so we divide by molar mass. Then we convert our hydrogen to moles. We make a comparison. 0.133 is smaller than 0.152. So we need to divide them both by that. So when we divide, we get 1, and then we get 1.14. So if you weren't careful, you may have thought that that rounded down, but that's roughly 1.15. And in the calculator, if you just started saying that times 2, that times 3, that times 4, and so on, eventually you would get to times 7. And times 7 gives you 8, or 7.99. So 1.14 times 7 gives me 8. So I need to multiply both of my elements by 7. That's how I get C7H8. All right, and the last problem, given this, what is the empirical formula? Go ahead and pause the video and restart when you have your answer. So if you said D, you are correct. This one, after all those long problems, was the super easy one. I gave you a molecular formula, you just had to reduce it down. Reducing it, 2 goes into both of them, giving you N3O5.